Welcome to our structural equation modeling training. In previous session, we have finished with CFA analysis. In this session, we will look in detail into the estimation of structural model. We'll start by going back to the Bagozzi paper and his research hypothesis. Specifically, Bagozzi suggested several relationships between his constructs. In this session, we will examine two of those relationships: the relationship between motivation and performance and job satisfaction and performance. And these can be expressed in terms of two research hypotheses. Hypothesis 1, that motivation influences performance, and hypothesis 2, that job satisfaction influences performance. If we were to depict those relationships graphically, we'll have a free construct models joining motivation, satisfaction, and performance through two hypotheses. Let's go to Amos software and try to estimate such model. I have opened the Amos software and I've opened the file which contains our CFA3 construct model. I'm going to rename this file, go to Save As, SEM3 construct model, and save it. I'm going to save it on my desktop. To change a CFA model to SEM model, you need to change the covariances between constructs into path relationships. We will do that by first deleting those covariances here. And then drawing path relationships. This is done by picking this one-sided arrow and entering into the picture. Our hypothesis suggests that motivation influences job satisfaction and that job satisfaction influences performance. You see, I've added those arrows there. A couple of other things we need to change. All endogenous variables within the model, in our case job satisfaction and performance, have to have an error term. So we'll click this button and then click the endogenous variable to insert those terms. As you see, those terms are unnamed, so we have to go to plugins, name unobserved variables, and now there is an error term associated with an endogenous construct. We will also change the analysis properties. Click on this button. Specifically, we would like to adjust the output to include the last option here, modification indexes. Tick that. OK, close. And now let's run our estimates. Nothing has changed on the main picture, but if you click on the red arrow, you will see some values popping up here. We are interested in the standardized estimates. See here? So we have our structural model estimated. To look for more details, we will go into our text file. Click here, which opens Amos output. To interpret the model, you first need to check model fit, whether this model is indeed suitable for interpretation. So we run through the usual checks, starting with chi-square quite high, good, but you will notice here that things are starting to go pear-shaped. A value that we are looking for is below 2, our value is above 2, still acceptable but not great. You will see the same worsening of things across indicators, and CFI is notable. As you will recall, the acceptable value is 0.95 and we have 934, which is below acceptable. If you scroll down, you will notice that RMSEA has dropped below the accepted level. It's 0.084 and the lowest threshold we will accept is 0.08. This model is not good. We need to see if we can improve it before we are actually able to interpret it. To see if the model can be improved, we go to a new menu here called modification indexes. The values presented here, the MI values you're looking for, show you that If you change, so if you, for example, introduce a covariance between motivation and error 14, you will get a better model. Now, we don't mess with the errors. To change the model, we will go to the box below, see if we can introduce relationships between some variables that improves the model. And specifically, we are looking whether there should be some paths between constructs. And this line here says to me that if I add an arrow leading from motivation to performance, then the model will improve significantly. You are looking here for values above 20. This is 74. Let's give it a try. So let's close the Amos output and go back to our graphical interface. We will click on this arrow here, which enables us to draw things and add that relationship between motivation and performance. We've added that, modified the model, and now we recalculate and go back to the output to see how things are now. Let's click on model fit and analyze the indices again. You will see now the chi-square, normed chi-square is below 2. Very good result. You will see improvement across all the indices, including CFI, which is now on 0.991, which is above the threshold value 95. And then, most importantly, our RMSCA has now dropped to 0.031, which is well below the accepted level of 0.05. Great, we can interpret the results. To check further result, we click on estimates. Recall that we started the session wondering whether there was a relationship between our latent constructs, for example, whether motivation affects job satisfaction. To confirm whether this relationship exists, you look at the table containing regression weights. Specifically, in the row marked P, 3 stars indicate significant relationships. We can tell that the relationship between motivation and job satisfaction is significant, and so is the relationship between motivation and performance. Unfortunately, performance and job satisfaction are not related anymore. Here you also check whether all the other indicators are still significant. So we see that the indicator variables like JS3 are still significantly related with the measurement constructs. Then we go below to standardized regression weights to see how strong are these relationships. And you will see that motivation affects job satisfaction, and it's a moderately strong relationship at 0.244. And that motivation also affects performance, and that relationship is much stronger at 0.616. Incidentally, these two tables also provide you with all the information you need to report when reporting the testing of your research hypothesis. In the first column here, you have non-standardized estimate, and this is usually not provided. Neither is this standard error. However, you typically report t-value here and the significance level. You also include the value of the standardized estimate. I'll show you how it's done in the next session, where we'll go through 5 construct model. See you then. Bye.